Congratulations, you made it. This is the 8th and final week of this class on functional analysis. Today, we are going to combine all of what we learned so far during these past 7 weeks to solve a real-life problem. Earlier, we talked about the rugby kick problem. Remember, I was in the rugby field at École Centrale Paris. We also talked about modeling the impact of the sun on the Eiffel Tower. Well, today we're going to talk about a different problem, a third problem, simulating a membrane. What happens if I actually put my finger on the membrane and push? What is going to be the shape of the membrane in this case? So first, let me take you to the labs of École Centrale Paris for a tour, and I will be back here to explain to you what is the problem we're going to solve. Welcome to the labs. It is a pleasure to introduce Guillaume Puel, who is an associate professor here at Centrale Paris and is in charge of the experimental activities for the students. Guillaume?
Thank you, John. For this simple experiment, we have clamped a very thin membrane made of latex on a cylindrical frame, and then we have increased the pressure within the cylinder in order to apply a force going upward and then to see the deformation of the membrane.
Thank you, Guillaume. So we're going to see this force F moving upward, and then we will, in the next videos, model this membrane, see what are the equations that govern the phenomenon, and then actually go all the way to the numerical simulation. So there are a lot of experiments that take place here at École Centrale Paris. A lot of modeling, a lot of computing, and we have high-performance computers here at Centrale Paris. What we're going to do today is a little less complex, because what we're going to do is model the impact of a force on a membrane. What happens when we put a force on a membrane? Can we model it? Can we compute the solutions? This is what we're going to do this week, so let's get started.